Regrooved car tires are time bombs waiting to explode. Regrooving is removing rubber from one tire groove to make it deeper and look newer, or creating illegal grooves in a worn tire. Some people think that they found a way to give new life to old tires by regrooving them, but it is total disregard for human life in pursuit of selfish gain. Unsuspecting innocent lives are getting lost from this practice. The car stabilizing pliers are super tough, we know, but they are also so delicate that whenever they are exposed, the tire should be scrapped immediately. Whenever the ply is visible to the eye on a tire, like is indicated on the tire diagram, there are no ifs or buts. The tire should be removed from use immediately. To understand what happens when a car tire is grooved, let us study the tire a bit. A tire is made of 5 major components or sections: the crown, the sidewalls, the bead area, the casing ply, and the interior of the tire. The crown is where regrooving occurs, so we're going to be spending time studying the crown so that we understand what really happens when a car tire is regrooved. When regrooving takes place in the crown, 3 major parts of the crown are affected directly: the tread ridges, otherwise called the tread block, and the tread grooves. And the third one is the stabilizing plies. The tread block or ridge is the raised part of the tire's tread pattern that makes direct contact with the road surface. These blocks are usually arranged in a specific pattern across the tire tread and designed to provide grip, traction, and stability in various driving conditions. Tread blocks come in different shapes, sizes, and configurations depending on the intended property or application of the tire, such as is it for dry traction, is it for wet traction, for cornering, off-road performance, or high-speed handling, or a combination of 1 or 2 or 3 of these. Functions of the tread ridge or tread block. We have grip and traction. The ridges or tread blocks provide contact points between the tire and the road surface, enhancing grip and traction. The design and arrangement of the ridges can vary depending on the intended application of the tire. Cornering. The tread blocks help to avoid skidding and maintain stability and control during cornering maneuvers by providing additional surface area and grip. The rigidity and shape of the ridges influence the tire's responsiveness and handling characteristics. Braking. The ridges play a crucial role in braking performance by increasing the tire's contact area with the road surface, allowing for more effective braking and shorter stopping distances, especially in wet or slippery conditions. Wear. The design of the ridges also help to distribute wear evenly across the tire tread, extending the tire's lifespan and durability. Noise reduction. Tread blocks are designed with varying sizes, shapes, and angles to minimize noise and vibration while driving, resulting in a quieter and more comfortable ride. The tread groove. A tire tread groove or channel is the space or indentation between the tread blocks on the tire surface. Grooves are designed to channel water, mud, snow, and other debris like entrapped stones away from the tire's contact patch to enhance traction and reduce the risk of hydroplaning or skidding in wet or slippery conditions. Grooves come in various depths, widths, and patterns depending on the tire's use and the desired level of performance in different driving conditions. Functions of the tread groove. Water dispersion. The grooves or channels between the tread blocks help to evacuate water from the tire's contact patch with the road, reducing the risk of hydroplaning and improving traction on wet or flooded roads. The design, depth, width, and orientation of the grooves determine the tire's ability to disperse water effectively. Sand and mud traction. Grooves also help in providing traction in sand, mud, and other off-road conditions by channeling away loose materials and allowing the tread blocks to maintain contact with the road surface. Heat dissipation. Grooves help dissipate heat generated during driving, particularly during high-speed or heavy-duty use, preventing overheating and maintaining tire performance and integrity. Debris expulsion. The design of the grooves built into it the ability to eject small stones, gravel, and other debris from the tire tread, reducing the risk of punctures, cuts, and other damages to the tire. Enhanced stability. Well-designed grooves contribute to the overall stability and performance of the tire by improving traction, reducing the risk of skidding, and enhancing handling in various driving conditions. The stabilizing plies. The stabilizing plies, also known as the carcass or body plies of the car tire, are made of layers of fabric material that provide structural support and strength to the tire. The most common material used for these plies is polyester, though other materials such as nylon or rayon may also be used. Polyester is often preferred for its combination of strength, durability, and flexibility. It provides a strong and resilient framework for the tire crown, helping to maintain its shape and stability even under heavy loads and high speeds. Polyester plies also help absorb impacts and vibration from the road, enhancing ride comfort and handling. In addition to polyester, some other high-performance tires may use nylon or rayon plies for added strength and performance characteristics. Nylon is known for its exceptional strength and heat resistance, making it suitable for demanding driving conditions. Rayon, on the other hand, offers a balance of strength and flexibility, contributing to a smoother and more comfortable ride. The stabilizing plies of a car tire play a crucial role in providing structural support, strength, and stability to the tire, ensuring safe and reliable performance on the road. Functions of the stabilizing plies. Provide structural support. The stabilizing plies serve as a framework, one of the main supporting structure of the tire crown, providing structural support and strength to withstand the forces and stresses encountered during driving, such as vehicle weight, road impacts, and internal tire pressure. Maintain tire shape and stability. The stabilizing plies help maintain the tire's shape and stability, ensuring that it retains its intended size, profile, and dimensions under various driving conditions. They prevent the tire from deforming excessively or collapsing under load, maintaining proper contact with the road surface for optimal traction and handling. Absorb road shocks and vibrations. The flexible nature of the stabilizing plies allows them to absorb impacts, shocks, and vibrations from the road, providing a smoother and more comfortable ride for the vehicle occupants. They help dampen road irregularities and minimize the transmission of vibrations to the vehicle suspension system and chassis. Contribute to tire flexibility and responsiveness. The arrangement and orientation of the stabilizing plies influence the tire's flexibility and responsiveness to steering inputs, acceleration, and braking. They allow the tire to bend and flex as needed to adapt to changes in road conditions and driving maneuvers, enhancing handling and control. Distribute internal tire pressure. The stabilizing plies support the distribution of the internal inflation pressure evenly across the tire's straight surface, ensuring uniform contact with the road and minimizing the risk of uneven wear or tire damage. They play a crucial role in properly distributing the tire inflation pressure and enhancing stability during operation. Enhanced puncture resistance. While not their primary function, the stabilizing plies also contribute to the tire's resistance to punctures and cuts by providing an additional layer of protection against sharp objects and road hazards. They help prevent damage to the tire's inner components and maintain tire integrity in challenging driving conditions. Reduces rolling resistance. Rolling resistance refers to the force required to overcome the resistance of a tire as it rolls along the road surface. Stabilizing plies are made of choice, lightweight yet durable materials like polyester or nylon, which play a crucial role in minimizing rolling resistance. Their flexible property allows tires to conform to road surfaces, reducing deformation and frictional losses. By evenly distributing internal air pressure, they ensure consistent tire contact with the road, optimizing efficiency. Their construction is carefully optimized for a balance of strength and weight, using advanced techniques to minimize energy losses. In essence, stabilizing plies help tires roll more efficiently, thereby reducing rolling resistance. Increase mileage performance. The stabilizing plies contribute to increasing mileage through their role in enhancing durability, reducing wear, optimizing rolling resistance, providing consistent performance, and resisting environmental factors. The cross section of the tire that we see in this case, where a lot of things happen, as a matter of fact, where everything happens when it comes to regrooving is the crown. And this is the crown of the tire. All this part of the tire is a crown. Then we have the sidewall. Then we have the bead area. This is replicated in both sides of the tire, like we know. And then we now have a very formidable and important part of the tire called the casing ply. Now the casing ply that you see here actually starts from the bead area where you have the upturn at the bead, and then it goes round through the sidewall onto the crown, then to the other sidewall, and then goes right to the bead of the other one and ends there. So, excuse me. So the casing ply actually is in every part of the tire. That's an information I thought we should all know. So once again, let's look at this schematic cross section from here. This area of the tire is the crown. This area is the sidewall. This area is the bead. And like I said, this is the casing ply. It's very important we know this. And this knowledge will help us to understand how the regrooving of a car tire works and how it is a danger to the tire. Like I said earlier, regrooving takes place in the crown of the tire. Okay? Here you have this whole area rather is the crown of the tire. In the crown of the tire, you have the tread rubber, which is the part that gets in contact with the road. Then you have the stabilizing plies. These are the stabilizing plies here. Okay, there are normally different numbers of them, between 3 to 4, and with made up of different materials. And then, like I said, we have the casing ply underneath. So this whole area, the tread rubber, the stabilizing plies, the casing ply make up the crown.
Same thing here. Why I like this diagram actually is that it gives you a better view of the stabilizing plies. Of course, this whole area is the crown. You have the thread rubber here, the part that comes in contact with the ground. Then you have the stabilizing plies. You can see them clearly here. This one has 1, 2, 3, 4 different types of stabilizing plies, and these stabilizing plies are actually arranged in different angles, and each of the angles have got different reasons. And by the side here, you see the casing ply.
The regrooving process. Now, this is our schematic diagram of the tire crown, all right? And this part is the allowable legal limit for the thread rubber usage. As a matter of fact, usage up to 3 millimeters of the thread rubber groove. So if this is the groove, all right, usage up to 3 millimeters of the thread rubber groove is the allowable limit for a tire. Okay, so the allowable limit is actually from this portion to about 3 mm before the depth of the groove. Now, the tire is used up to its allowable limit before it is regrooved. All right, so that means that the legal requirement of the tire is actually normally used up before it is regrooved. Now, the regroove starts from the expiration of the legal allowable limit. Can you see that? The regrooving starts from the expiration. So the legal allowable limit has been reached. Okay, the tire is supposed to be scrapped. Now, the illegal regrooving of the car tires now starts. So what now happens is that the regrooving now remove the rubber beneath the groove. It removes this rubber beneath the groove. This rubber beneath the groove is what it removes. All right, so it actually eats up this rubber. Okay, so the rubber it removes is dangerously below the safety limit. Sometimes it exposes the plies like we see in the diagram below. So what happens is that when the regrooving starts, they actually remove the rubber that is below the allowable limit, this up to this point, and remove this one. So sometimes they actually remove so deep that, like we saw in the diagram, that we now see that white stuff we're seeing is this ply of the tire. All right, when we're now seeing the stabilizing plies, that's what we see. All right, and normally, not even normally, it is not supposed to be visible to the eye. The stabilizing ply is not supposed to be visible to the eye because it is not supposed to come in contact with moisture or anything like that. Effects of regrooving a car tire. Two basic things happen when a car tire is removed. One is that new illegal tread ridges or tread blocks are formed. All right, so we now have tread blocks. I mean, the former one, this one that the original one is gone, we now have new ones formed. New tread block, a new tread block. This is a new tread block. This is a new tread block, and another new tread block. So you see that new tread blocks that are illegal are formed. Now, new illegal groups are formed also. So you see this one now, that you have a new groove here, legal, another groove here, and a new groove here, and of course a new groove here. These are all illegal new tread grooves. Now look at the stabilizing plies. We see that
The new tread grooves are actually formed directly on top of the stabilizing plies. See this groove now. On this one, there's no way this one won't show, because this one are actually, the rubber here has been removed, and then we now have the stabilizing plies here. The rubber here has been removed, and we now have it. We now have this ridge, this tread block, sitting on the stabilizing plies directly. But ideally, it's supposed to be sitting on a rubber like this. But you see here, we now have the tread block sitting directly on the stabilizing plies.
New tread blocks or ridges compromise structural integrity. When the tread rubber is regrooved, it removes a significant portion of the tire's original tread depth. Furthermore, it cuts deep into the pattern's base rubber, sometimes exposing the cable plies. The tread blocks consequently do not have the base rubber to stand on, making them lose the ability to grip the road. This compromises the structural integrity of the tire, reducing its ability to withstand the forces and stresses encountered during driving, such as impacts, road friction, and heat. Reduced traction and grip. Regrooving results in uneven tread patterns and reduced tread depth, compromising the tire's ability to maintain traction and grip on the road surface, especially in wet or slippery conditions. This increases the risk of skidding, hydroplaning, and loss of control. New tread grooves. Exposure of underlying plies. Regrooving removes the protective layer of tread rubber, exposing the underlying stabilizing plies of the tire. These plies are not designed to come into direct contact with the road surface and may be more prone to damage from road debris, sharp objects, and other hazards. Perforation. Regrooving makes a tire much more prone to damages like punctures, as the protective rubber layer has been removed. Increased risk of tread separation. Regrooving eats away the residual base rubber, exposing the underlying plies to moisture. Moisture weakens the bonds between the tread rubber and the underlying plies, leading to tread separation. Tread separation occurs in three ways. 1. Separation between the tread rubber and the underlying plies. 2. Separation between the plies. And 3. Separation between the ply and the tire carcass. Tread separation is a tire failure that can lead to a blowout. Identifying regrooved car tires. Number 1. Inspect the tread for signs of regrooving. Before purchasing a tire, inspect the remaining tread depth carefully. If the tread depth appears uneven or inconsistent, and there are shallow cuts or grooves that extend beyond the original tread depth pattern, with some areas having significantly less tread than others, this indicates that the tire has been altered by improper regrooving. Number 2. Check for tread wear indicators. One way to identify regrooved tires is that they have no tread wear indicators. The process of regrooving removes the tread wear indicators. Number 3. Check for exposed plies. Examine the tire's tread surface for any signs of exposed plies or cords. If you can see the underlying plies through the tread rubber, the tire has been regrooved improperly, compromising its structural integrity and safety. 4. Consider the source. Purchase tires from reputable dealers or retailers who have a track record of selling quality, properly inspected tires. Avoid purchasing tires from unknown or unreliable sources, as they are more likely to sell improperly regrooved or damaged tires. 5. Consult a professional. If you are unsure about the condition of a tire, consider having it inspected by a qualified tire technician or mechanic. They can provide expert advice and guidance on whether the tire is safe to use and whether it has been regrooved improperly. Conclusion. Overall, regrooving car tires significantly compromise their safety, performance, and longevity. It weakens the tire crown structure, reducing traction and grip. stimulates tread separation and tire failure, and poses danger to both the driver, the occupants, and other road users. It is important, therefore, to never use regrooved car tires and instead replace with new tires when they reach the end of their usable tread life. Additionally, it is essential to only use tires designed for the application for which the vehicle is used for, to ensure safe and reliable operation of the vehicle. By carefully inspecting the tread depth, looking for signs of regrooving, checking for exposed plies, inspecting for damage, considering the source and consulting a professional if necessary, you can identify and avoid purchasing car tires that have been wrongly regrooved. This way, you choose the right tire for your application, thereby ensuring the safety and reliability of your tires and reduce the risk of accidents and tire failures on the road. Thank you for taking the time out with me to understand why a regrooved car tire is a time bomb waiting to explode, and avoiding purchase or use of a regrooved car tire by studying and understanding what regrooving does to a car tire and looking at the various functions of the components of the tire affected by regrooving and how they lead to dangerously compromised tires and a risk to lives. I would like to point here that it is car tires that are not supposed to be regrooved that are dangerous and time bombs waiting to explode. There are certain truck tires that are actually regroovable, okay? And when those truck tires are regrooved, they don't pose any danger. They are actually the ability and the capacity to be regrooved are actually built into these tires, and they actually serve to elongate the life of the tire and are cost saving and better for return on investment of the tires when done properly. So please, let's be clear that it is not truck regroovable tires that we are talking about here. We are talking about car tires, because car tires are not supposed to be regrooved. Do join me in subsequent journeys into tire awareness. So till next time, shalom.